In the today's lecture of automobile engineering, we are going to see the engine construction and detail about the engine parts. The function and construction of the each part of an internal combustion engine are to be studied. Therefore, the essential parts of the engine please note down as cylinder block, cylinder head, crankcase, piston, piston rings, piston pin, connecting rod, crankshaft, flywheel, valves and valve mechanism, rocker arms, camshaft, accessories that include air cleaner, oil filter, automatic chokes, automatic heat controls, and other parts that includes spark plug, ignition devices, carburetors, manifolds, and vibration dampers. Cylinder blocks, cylinder head, and crankcase. Now these three parts form the foundation and main stationary body of the automobile engine. Now a cylinder block consists of three parts as the cylinder in which pistons slid up and down, the ports or openings for the valves, and the passages for the flow of cooling valves. Cylinder block is usually made from grey cast iron and sometimes with addition of nickel and chromium. Some blocks are cast from aluminium in which cast iron or steel sleeves are used. For most engines, cast iron has been found to be a satisfactory cylinder wall material as it has better wearing qualities. The L-head engine block contains opening for the valves and valve ports. In some places, lock washers are placed under the nuts or bolt heads. Water-cooled engines have passages surrounding each cylinder wall and spark plug. The circulating water maintains the engine in its correct working temperature and avoids excessive expansion and hence distortion, ultimately preventing the seizure of relatively moving parts. Cylinder head. The top of the cylinder is covered by a separate cast piece known as cylinder head. The cylinder head is bolted to the top of the cylinder block. It contains combustion chamber, spark plug, and sometimes valve in either I and F head are mounted in it. It incorporates passages for the flow of cooling water. Depending upon the valve layout, the cylinder head may carry the camshaft, rockers, and valves. Water passages are provided adjacent to the valve and plug settings. From the mechanical point of view, the design details of detachable cylinder head are perhaps most difficult. Now, the care should be taken to the following points where detachable heads are made. That is, the bore of the cylinder or liner should not be distorted by the pull of holding down studs. The circulation of coolant in the cylinder head should be carried as nearly as possible to the top end. To ensure a sound gas tight joint, the holding down studs must be distributed as uniformly as possible around the circumference of each cylinder. Now, advantages of aluminum alloy cylinder and head. They have higher heat conductivity, which is about 3 times that of cast iron. They are light in weight, increased compression ratio without detonation due to the heat conductivity, better cooling while the engine is running, greater power output and low fuel consumption due to increased compression ratio and better cooling effect. Now, engine warms up more quickly and requires a smaller radiator. But when we consider the disadvantage, the engine costs more due to costly aluminum alloy. It is liable to crusted out of shape by holding down studs due to low modulus of elasticity. Due to higher thermal expansion, greater clearance is required between the piston and cylinder. Greater possibility of corrosion by cooling water. Sometimes it is necessary to use cast iron, valve springs and spark plug inserts. Due to intermetallic corrosion between steel studs and aluminium, the head may stick to cylinder block. Now, cylinder head gaskets. In the cylinder head gaskets, you have to consider following important points that these are the different types of gaskets you can use. They are copper asbestos, steel asbestos copper combination, single steel ridge or corrugated gaskets, then stainless steel gaskets. Some of the gaskets are produced in the combinations also. Now, when we consider cylinder head gaskets, they are metal sandwich type gaskets or embossed steel or shim type gaskets or shimbestos. It's a combination of thin steel head shield on one side and high resilience specially treated metal reinforced asbestos on the top side. And another is felbestos. Then there are oil pan gaskets, and manifold gaskets are of 3 types as metal encased asbestos, felbestos, again metal encased shim gaskets, and pump gaskets. When we talk about crankcase, It is attached to the bottom face of the cylinder block and it acts as the base of the engine. It supports the crankshaft and camshaft in suitable bearing and provides the arms for supporting the engine on the frame. Then oil pan or sump. The bottom half of the crankcase is called oil pan or sump. It is bolted or screwed to the lower flange of the main casting and usually made up of pressed steel or aluminum. The oil pan serves as a reservoir for the storage, cooling and ventilation of engine lubricating oil. Cylinder liners. The problem of cylinder wear is considerable and this has been solved by the use of cylindrical liners. The cylinder liners are in the form of barrels made up of special alloy iron containing silicon, manganese, nickel and chromium. They are cast centrifugally as it is now customary to fit cylinder liners on engine of cars and commercial vehicles. They are divided into dry liners and wet liners. Now, when we compare dry liners with wet liners, few points that has to be mentioned, like a wet liner can be replaced easily and for this purpose there is no need of special tool or equipment. A wet liner is in direct contact with circulating water and hence reduces piston temperature. Likewise, we can differentiate between wet liner and dry liner. Next is a piston. It is considered to be one of the most important parts in a reciprocating engine which helps to convert chemical energy obtained by the combustion of fuel into useful mechanical power. The purpose of the piston is to provide a means of conveying expansion of the gases to the crankshaft via the connecting rod without loss of gas from above or oil from below. Now, piston is essentially a cylindrical plug that moves up and down in the cylinder. It is equipped with piston rings to provide a good seal between the cylindrical wall and piston. The efficiency and economy of the engine depends on the working of the piston. The piston should have following qualities. I will mention 2-3. First was rigidity to withstand high pressure. Second, good heat conductivity to reduce risk of detonation, so allowing higher compression ratio. Then, silence in operation. Lightness to reduce weight of the reciprocating masses. Material having low expansion and provision to allow for different expansion rates of cast iron cylinder block and aluminum pistons. Next, the material for pistons is mainly aluminum alloy. Aluminum pistons can either be cast or forged. Cast iron is also used for piston. Then piston clearance. The clearance is essential in the piston because of following reasons. It provides a space for a film of lubricant between the piston and cylinder wall to reduce friction. It prevents piston seizure. If there is no clearance between piston and cylinder, it will be impossible for the piston to reciprocate in the cylinder. Now, expansion control in pistons is achieved by several methods. Few methods we will enlist as by keeping heat away from the lower part of the piston as much as possible, and this can be done in full sculpt piston by cutting horizontal slots in the piston just below the lower oil controlling groove. Second method is by making heat dam. Heat dam consists of a groove cut near to the top of the piston. This reduces size of the path the heat can travel from piston head to skirt. The skirt therefore runs cooler and does not expand much. Next method is by cam grinding the piston. The pistons are finished so that they are slightly oval or elliptical, that is when cold. These pistons are called cam ground pistons. Now, when cam ground piston warms up, it assumes a round shape. Next is by using struts. The piston expansion may also be controlled by using the struts, bands or belts cast iron into the piston. This causes the outward thrust of the expanding piston, that is to be carried more towards the piston pin bosses than toward the thrust face, so that the effect is similar to that of the cam road piston. Now, high performance pistons. For additional strength, some high performance pistons have special skirt configurations, that is low X alloy pistons, in which light alloy for piston may be including silicon 11 to 13%, nickel 0.7 to 2.5%, magnesium 1%, copper 1% and aluminum ranging from 86.3 to 92.5%. So likewise, this is the condition related with piston. There are other types of pistons as autothermic pistons, bimetal pistons, special oil pistons, well-worthy pistons, etc. We talk about combustion chamber, that is the space enclosed between the piston head and cylindrical head when the piston is at the top dead center, that is TDC position, and it extends up to the upper compression ring of the piston. Exhaust and inlet valve open and close in the combustion chamber and the spark plug projects in it. The design of the combustion chamber is of great importance for the engine performance because the air fuel mixing and combustion takes place in it. Depending upon the location of the spark plug, walls and types of cylinder, combustion chambers are of following shapes. It can be of spherical shape, it can be of I shape, it can be of T shape, it can be of F shape, also it can be of L shape. So this is the information related to this combustion chamber. We'll move with the piston rings. Piston rings are fitted into the grooves of the piston to maintain good seal between piston and the cylinder wall. Now there are three functions of the piston rings: to provide a pressure seal to prevent blow-by of burn gases. Blow-by is the name that describes escape of burn gases from the combustion chamber past the piston and into the crankcase. Second function, to form the main path for the conduction of heat from the piston crown to the cylindrical walls. And third, to control the flow of oil to the skirt and rings themselves in adequate quantity while preventing an excessive amount reaching the combustion chamber with consequent waste and carbonization. The material used for the piston rings are fine-grained alloy cast irons, as this possesses excellent heat and wear resisting quantities inherent in its graphite structure. Elasticity of this material is also sufficient to impart radial expansion and compression, which is necessary for assembly and removal of the ring, and particularly to enable it to exercise flexible pressure on the cylindrical walls. Now we'll move forward. Next is oil control rings. Before going to oil control rings, there is a question that will be asked: why two compression rings are used? Usually, two compression rings are installed on the piston during the power stroke as the pressure increases as high up to the 70 kgf per centimeter square, and it would be difficult for a single compression ring to hold this much pressure. If there are two rings, this pressure will be divided between the two rings. The loss of pressure past the upper ring is reduced. The load on the upper ring is also reduced so that it does not press quite so hard on the cylinder wall. Wearing of the ring and cylinder is also reduced. Therefore, we use two compression rings. Next, we are going to see is connecting rod. The connecting rod is the connection between the piston and crankshaft. It joins the piston pin with the crank pin. Small end of the connecting rod is connected to the piston pin and big end to the crank pin. The function of the connecting rod is to convert linear motion of the piston into rotary motion of the crankshaft. The connecting rod usually has I-beam cross section and is made up of 4 steel. There are two types of small end and big end bearing used in the connecting rod segments. Crankshaft is the first part in the power transmission system on which the reciprocating motion of the piston is converted into the rotating motion with the help of connecting rod. A crankshaft consists of crank pins, webs, that is crank arms or cheeks, balancing weights and main journals. Big end of the connecting rod is connected to the crank pin of the crankshaft. Center to central distance between the crank pin and crankshaft is half of the piston displacement during a stroke. Therefore, one complete revolution of the crankshaft makes 2 strokes of the piston. The parts of the crankshaft inside the main bearing are called main journals. Next, valve is a device to close and open a passage. In motor vehicle engines, 2 valves are used for each cylinder: inlet or intake valve and an exhaust valve. The valve used in modern passenger car engines are termed as poppet or mushroom valves. Valve mechanisms are of 2 types: valve mechanism for operating the valve in engine block, that is straight poppet valve, and valve mechanism for operating the valve in cylinder head, that is overhead poppet valve. Now we will go further and we will see valve cooling. It is obvious that exhaust valve runs hotter than the inlet valve because the exhaust valve is always in contact with the hot gases, while the inlet valve is somewhat cooled by incoming fresh air. The exhaust valve may actually become red hot during a short period of operation. The valve face is hottest and valve stem is coolest part in a valve. Therefore, the valve stem passes heat to valve guide and the valve face passes heat to the valve seat, and this helps to keep the valve cool. Now this is the cooling system used in a valve. A camshaft is a simple shaft on which cams are mounted. The camshaft is mounted in bearings in the lower part of the cylinder block in most inline engines. In a few engines, it is located on the cylindrical heads. A V8 engine is located in between the 2 banks of the cylindrical. So dear friends, with this we have completed the module associated with the engine construction. We will continue the same series of lectures in the next time. Till then, thank you.